Hey guys, Happy-Go-Logger here, back for another maths question of the day. We're working our way through the IGCSE 2020 Specimen Paper 2 now, extended questions, and this question's about area of a trapezium, and it's not as easy as it first looks. The question goes as follows: calculate the area of this trapezium, but no height. Press pause, have a go at the question, and I'll be back with the work solutions in 5, 4, 3, 2, 1. Okay guys, back with the work solutions. The normal formula for area of a trapezium could be done two ways. The first way would be probably an easier method, is to break it down to two smaller shapes, a rectangle and a triangle. And the other is to use the formula, which you might forget. So if you add your parallel sides, divide it by 2, and multiply by the height. The problem is we don't have a height right now, so we're going to have to work it out. Well, we know that there's a rectangle going across here. So the first one we can work out, if this whole way across is 12 and up to the rectangle is 8, then we know this space here has to be 4. And if you look closely, that's going to be a right angled triangle. So we can use our Pythagoras skills, and a quick refresher on how to use Pythagoras' theorem. When you want to find the side length of a right angled triangle, you have to do short side squared, which normally you call A, plus the other short side squared, which we call b, and that will give you the diagonal, the hypotenuse squared, and then your square root to find the answer. So a little bit of Pythagoras hidden in this question, and that explains, that kind of justifies the 4 marks that's available for this question. So let's move on to the using Pythagoras. If we've got a base of 4, that's one of the shorter sides, and a longer side of 8, then we need to rearrange the formula to say, to find the shorter side, you do big side squared, take away shorter side squared, gives you the other shorter side squared. So we need to get a calculator on that. It's going to be 64, take away 16. But we're going to have to square root that, so let's get a calculator out. 64, 8 squared, take away 16, 4 squared is 48, but then we need to square root that. On this calculator, you have to do a second function, and there's your square root button down below. So check your calculators and make sure that you know where the square root button is. So we'll get the answer 48, and the square root of 48 is that big number there, 6.928203, and so on. Let's move that to one side for now. 6.93 to 3 significant figures. Or if you really wanted to, you could leave that as root 48 for now. Either way of doing this, you'll still get the marks. Okay, so we've worked out the height of this trapezium to be 6.93 to 3 significant figures. So now we can go back to our formula and just plug everything in. So we need to add the parallel sides. So that's going to be 12 plus 8. That's 20. Cut it in half. That's 10. And then multiply by the height. So 10 multiplied by 6.93, or 10 multiplied by root 48. And as we've still got it in our calculator, all we've got to do is multiply by 10, and there's your answer. So now it's 69.282, but still to 3 significant figures, it is just multiplied by 10. 69.3 to 3 significant figures. 69.3. So 4 marks available. It's quite a big, deep question, that. You get 2 marks for working out all the Pythagoras bits to get the height, and then plugging it into the formula for the trapezium, you would get a 3rd mark, and actually popping out with the right answer, 69.3 centimeters squared. That's your 4th and final mark. Okay, hope you enjoyed that question. You learned something from it. I've been Happy-Go-Lucky, and today you've been working out the area of a trapezium when you've had to find out the height using Pythagoras. Good for you guys. Thanks for watching. I'll see you again soon. Bye.